Edit out me having all the trouble to the car.
I kind of don't know how to turn it off. I pushed stop.
You're okay. We can keep rolling, right?
Recording.
Okay.
This red button right there. Now.
Good.
Hold on. We can't see your face.
I'll try and give me a shot. Are you good? All right. We're just outside today. We're doing a test on the gasoline vapor reduction system. I'm Jack Talbert with United Renewable, and the Oldsmobile Delta 88 that we converted to 1981 Oldsmobile. The intention behind this fueling system is to remove the atmospheric pressure from the meniscus of a body of gasoline in a liquid state to create a gaseous or vapor state. This was the original device that my father had used to do this. This is this little gasoline vapor reduction snorkel. It's got two butterflies on it, one on the top and bottom, and it's got an induction chamber in between the two sets of butterflies. And what we did was we recreated this, but we combined it with an existing carburetor. The idea was we were going to use the carburetor for the accelerator pump, but we wound up not actually using the accelerator pump. We wound up just using a vapor canister instead, and a flow control valve to richen the mixture out rather than using the accelerator pump. But this was the original device. I think he started on this in 1969, finished up the entire concept around 71. He died in 82, thought he had removed any material relating to the topic of gasoline vapor reduction, but we found it and made one of our own. So I'll show you how this one works, and then we're going to take it for a test drive and run up to see a mechanic real quick. So we'll get it. Now it'd be good if you could get a little mobile. Okay, we're going to carry on in here. This is a 350 cubic inch setup. We're not made under the most professional environments today. But I had to take the old air cleaner off because it wouldn't fit after we put the new carburetor on. This is a standard 4-barrel carburetor. This is the one that came on the car. What I did with this one was I gutted it, took all the guts out of it, and left in the accelerator pump, but I closed off any other openings so no fuel actually goes through the carburetor. The accelerator pump, the accelerator pump's still there, but the bowl is empty, so there's no fuel that goes through there. I don't know if you can get a good shot of this or not, but here's the old, this was the fuel line. That's a little wet, so I really need to get that sealed off better. It's leaking a little bit of gas out of the outside of the manifold. Actually, it's leaking quite a bit of fuel right there. I'll have to seal that up. Huh. That's leaking around a gasket. We'll get it fixed. Anyhow, I cut the fuel line off here, and so we don't bring any fuel into the carburetor itself. We don't use that part of it. This part is unhooked but left on the car. Now, the way the thing works is I have a fuel filter that has 1 in and 2 out. One side of the fuel filter goes to a vapor can. If you can get a good look at the vapor can, this vapor canister, fuel goes into it, there's a float in it. When it reaches a certain level, the float disconnects. And when the float disconnects and it reaches that particular level, the float shuts off. And when the float shuts off, it quits putting fuel into the can. Bottom half of the can has fuel, the top half has an empty space. This is vacuum line that goes to the carburetor. What it does is it creates a vacuum on the top, and it draws the gasoline fumes or the vapor off, the actual part of it that's a gas, from the meniscus of the liquid in the top half of it. And then it brings that into the carburetor base plate. And if you can look at the bottom, there's a base plate down here. And one of the fuel lines that I unhooked, I don't have it corked off very good, and I'm just looking, it's got a little bit of fuel that's on top of the manifold. I'm going to need to get the lines actually wet where it's spitting a little bit of gas out because my little bolt trick didn't work as well as I was hoping it would. The fuel line itself is severed right here, and I'm going to have to do something about that fuel dripping because I don't want to have the wet fuel on top of the cylinder. But anyhow, so this is a spacer plate on the bottom, and inside the spacer plate is an infuser that I made. And the infuser is just like any propane infuser. It's a little copper rod inside of a big steel rod. It has holes drilled through it like Swiss cheese. It draws the vapor off the top of the can. Here it's still little tiny droplets of fuel, but when it hits the infuser, then it's gas. Like, you know, when you uncork the top of a gas can on a hot day and you see a heat mirage, it's actual gas. It's not just little droplets. Then it intermixes the gas together with the air, and then of course the natural gravity of the situation pulls the entire air-fuel mixture down into the intake manifold where it's distributed to the head and then burned. And it burns fairly completely. It produces just pretty much pure carbon monoxide, and there's not a lot of unburnt hydrocarbons. And one of the things that we found was if you try and vapor the fuel before you get to where the manifold pressure is greatest at the base of the carburetor, it doesn't completely vaporize, and I think it's because there are detergents and additives in the fuel. And so that stuff all vaporizes at a different specific gravity and at different temperatures. So in order to get it to all vaporize evenly enough to clean to do it. And anyhow, if you get around on this side, you can see in the carburetor right there, we have this is the base plate I was talking about. That plus these gaskets stacked together make my vapor chamber. And so the entire chamber is, you know, a certain number of, given area, a certain number of cubic inches that's dedicated only to an empty space under the base plate. There's a set of butterflies here, throttle plate, a set of butterflies there, which is the throttle plate, and they're linked together. Now this runs the accelerator pump if it were hooked up because the linkage is still there, but the accelerator pump itself has an empty bowl behind it, so it doesn't actually provide any fuel. Link the two butterflies together so they open and close at the same time, and it lets the vapor through. This is the vapor recovery that comes out of the charcoal canister from the gas tank from the factory, and basically we found out if we made that a much smaller line in a much tighter confined area, you get enough vapor you can run the car from that little line, this itty-bitty tiny line over there. So all I'm going to do is try and start her up right now. Get my keys. And now we're going to take a ride. Gotta put it on with this little hole has to go away plate. Alright. And there's no choke, and it's cold today, so you know it runs rough at first because you know we got no choke. Okay, now we gotta run it from the vapor. And if you want to get in the car, we'll take a ride.
Right now.
Okay, you're recording?
Yeah.
Alright. I don't know how well you can do this, but can you see the flow control valve? That's my flow control valve. That's what mixes my vapor, and well, basically that allows I can choose how much vapor I wish to send to that vapor plate. And the way I choose that is by setting the flow control valve. Ideally, that has to be a mechanism that is controlled by the throttle linkage ultimately. This is a carbureted system. It would be better to do it as an injected system than a carbureted system. But right now, the way, if I want to accelerate, I can only get so much vapor, so I have to open the flow control valve more manually when I want to go faster. The greater demand I put on the fuel, the more I have to open the flow control valve. You know, it's a 4,000-pound car. So the more demand that there is put on the car, on the fueling system, the greater I have to open the flow control valve. And subsequently, the worse the mileage is, the greater it's open. But if we leave it open all the ways like it's highway use, then in town it floods and dies. And if we leave it set to the minimum, we can drive it on the highway, but I think both of you guys kind of remember what that was like, trying to drive on the highway without the flow control valve.
Not so great.
Not so great.
You even go to Chapman.
Yep. No, we made it. We made it Chapman. We flooded it because we had the flow control valve and I forgot to set it.
Explain that to them.
Already did. Well, with the flow control valve, it lets in as much or as little as you want. And what I did one time was I was set for the highway, and we were on the old highway 55-mile-an-hour limit, which this car likes 55. It doesn't like 65, 70s. It's not as happy, but it runs really happy at 55. And I had it set for 55 mile an hour on the flow control valve, and we came to a stop sign in Chapman, and I forgot to set it back, and it flooded. But it took a long time to start back up, and Stan Izzet came by in a car, and yeah, and he jump started it, or he helped us get it started, which was nice. So, and that's one of the things that I'm not overly, you know, I don't mind taking long trips with it, but once we start getting to peak and back trips, you know, it's better if I have someone that I know with me. And I gotta continually balance the flow control valve as we're going. And like right now we're going on a hill, so if I want to add that demand, I put in more fuel. And that's because with the vapor, I can't get more vapor just the same amount more often by increasing the flow control valve. But this car is every father's dream for his teenage boy to be driving, because it takes the skill to drive. You got to drive it real nice. Yeah, you really can't speed out.
Tell me about that.
The thing is if you try and speed out, it'll accelerate fine. You're just not burning dirt with it. You're not going to burn the rubber on the tires. On what? Tell them what?
We have 4 minutes left on this tape, I guess.
Well, we need to get. What we're going to do is we're going to go see my brother over at the shop, and because we got a surprise for him. But so we're going to go over there and see him real quick. So we'll see you in a minute. Are you rolling?
Yeah.
Good. Timmy.
What?
All right. You've been a mechanic for how many years?
Since I was born.
Since you were born. It was actually our father that had designed the system, the one that I showed you out of the trunk earlier, and that we modified for this right here. Basically what I did was I brought the car up here, and I want Timmy to kind of verify and explain a little bit more. We're not using the carburetor, all right? I'm going to start it up, but Timmy was running rough, and I had a little bit of a leak, and we got the leak fixed, so we're going to turn her up. Anyhow, Timmy, I need to go turn up the flow control valve a little bit. I need you to find where fuel is and isn't. Now, how do we verify that we have fuel going through the carburetor or not? You got a flat tire?
take a picture of the fuel line not connected up.
Okay, show that then.
Here's a video.
Can you get that? That's where the fuel line's supposed to connect up, and there it is, not connected.
Is it leaking?
No,
That line, okay.
not this time. See? Nothing. No fuel connector.
And if you get your fingers down in the jets, they're dry.
There's no gas in the carburetor.
No gas. So what we're doing is we're at least attempting to vaporize the fuel at the base plate. So, and I haven't been running it. I like to run the accelerator pump, but we haven't had it plugged in since we had the fireball on the carburetor. And it's real, like Timmy said, it's hard to see, but the other copper line down there where the light's on now, there, that's where the fuel droplets go into the diffuser to vaporize. And that's pretty much it.
Okay, we're recording.
You're recording? Okay, Timmy took the little pigtail part off so you can see, and if you can get a look down in there, you can actually see like you were looking into it from there, if you can get that. Well, you can see down in there that it's dry. There you go. Beautiful. Right down in there.